Hey everyone, and welcome. Today we're going to level up our game and really dig into the blockchain story. We're going way beyond just digital money to explore how this technology learned to think, how it became programmable, and why that turned it into such a powerful tool for, well, pretty much everything. But first, let's start with a big idea. Just imagine this. What if a contract didn't need lawyers or judges? What if an agreement between two parties could just run itself, automatically, perfectly, with no human getting in the way? Just hang on to that thought, because it's the key to everything we're about to unpack. So that idea, that's really the heart and soul of what we call blockchain 2.0. You see, the first generation, that was basically a super secure digital notebook for keeping track of who owns what. This next step, though, this was a revolutionary leap. It was about taking that secure notebook and giving it a brain, making it programmable. And the platform that absolutely blew the doors open on this revolution is Ethereum. Now, as you can see here, it's open source and decentralized, but the secret sauce is that smart contract functionality. That's the game changer. Ethereum wasn't built just to be a new kind of money. It was built to be a global computer, a platform where anyone could build and run their own unstoppable applications. And this brings us right to the main event, the magic trick that Ethereum unleashed, smart contracts. This is where that wild idea of a self-enforcing agreement stops being science fiction and becomes a reality. So what is a smart contract really? Well, in the simplest terms, it's just a piece of code that lives on the blockchain. The terms of a deal, like if this happens, then do that, are written right into the program. And once it's out there on the blockchain, it's immutable, meaning nobody can ever change it, and it's totally transparent. It just does what it was told to do, forever. And when you put them side by side like this, the difference is just night and day. A normal contract, it's all about trusting other people, trusting lawyers, and then relying on a legal system that can be slow and super expensive. A smart contract, it's trustless. You don't have to trust the person, you just have to trust the code. It enforces itself, which makes it fast, cheap, and it takes human error right out of the equation. Okay, so that all sounds pretty cool, right? But how does it actually work? What's going on under the hood that makes all this possible? Let's step into the engine room. At the very heart of Ethereum, you've got this thing called the Ethereum Virtual Machine, or EVM. The best way to think about it is like a single, giant, global computer processor. Every computer on the network runs a copy of the EVM, and it's this shared machine that reads the smart contract code and makes it run. It's the engine for the entire system. So, you've got this giant global engine, but how do you give it instructions? Well, you use a programming language. And for Ethereum, that language is called Solidity. It was built from the ground up specifically to write smart contracts. If you've ever seen JavaScript, it'll look kind of familiar. This is the language developers use to spell out the rules of the agreement. And how do we plug into all this? That's where an Ethereum wallet comes in. Now, don't think of it like the leather wallet in your pocket. It's more like your digital identity, your passport to this new world. It holds your unique keys, and it's what lets you sign transactions and actually use these smart contracts. So let's put all those pieces together. When you see it laid out, the flow is actually pretty straightforward. A developer writes the contract using Solidity. They push it out to the Ethereum network. The contract then lives and runs on the EVM. And then people like you and me can use our wallets to interact with it. Simple, but incredibly powerful. But, it's not all a perfect utopia. This incredible new power, well, it came with a whole new set of very big, very high-stakes problems. I mean, just think about it for a second. When your code can never be changed, and it's controlling, say, millions of dollars worth of assets, a tiny little bug isn't just a glitch, it's an absolute catastrophe waiting to happen. And the reason things get so complicated boils down to this concept called Turing completeness. Now, don't let the fancy name scare you. All it really means is that the programming language, Solidity, is extremely powerful. It's not just for simple if-then logic. You can build almost any kind of complex system you can imagine. And that power is a real double-edged sword. And this is where the rubber really meets the road. Because the language is so powerful. Trying to predict every single possible outcome, every weird edge case, every loophole, it's incredibly difficult. A tiny mistake in the code can have massive, irreversible consequences. And this verification challenge is still one of the single biggest headaches for developers in the space. And believe me, this isn't just theory. The history of crypto is littered with stories of major, high-profile hacks. Clever attackers find these tiny little bugs in the complex code and exploit them to drain millions, sometimes hundreds of millions, of dollars. The stakes could not be higher. So, all of these challenges, especially the security risks and the completely open nature of Ethereum, is what pushed the technology into its next phase, Blockchain 3.0. This was all about adapting blockchain for the unique needs of the business world. A huge name you'll hear in this space is Hyperledger. Now, this isn't another single blockchain like Ethereum. A much better way to think of it is like a big toolbox or a plug-and-play framework. It gives businesses all the components they need to build their own private, custom-built blockchain solutions without having to start completely from scratch. And this right here really nails the fundamental difference. Ethereum is permissionless. Anyone in the world can join. Hyperledger systems are permissioned. You know exactly who is in your network because you invited them. Ethereum is public and transparent. Hyperledger is private and confidential, built for sensitive business data. It's a shift from a computer for everyone to a highly specialized tool for industry. And all of this leaves us with one last really big question to chew on. We've seen this technology evolve from a simple ledger to a world computer, to a tool for global business. We've seen that code can be written to be unstoppable. So, if code really can become law, who do we trust to write it? That's a huge question with no easy answers. Something to think about. Thanks for joining me today.